So I've already told you that Newton's method is the fastest root-finding routine. Bisection is the slowest, and secant method is somewhere in between. So we ought to quantify that in some mathematical sense. That's the concept of order of convergence. So we're solving f of x equals 0 with some iteration method. So we end up with iterates x0, x1, x2, and so on. The root is going to be r, right? So that our sequence of x's is trying to converge to the root. So we want to kind of quantify what is the error in each of these iterates. So the error we define as epsilon n, and that's the difference between the root, the actual root, and the xn in the sequence. Okay? So what is order of convergence? So if the error, absolute value of the error of n plus 1 is equal to some constant times the absolute value of the error at the nth iteration raised to some p value, then we see that the method, we say that the method is order p. So p then is the order of convergence of the method. Okay? These errors are getting smaller and smaller, closer and closer to 0, so that if p is a larger value, then you will have faster and faster convergence. Okay? We can look at bisection. Bisection is rather simple to do. So for a bisection, right, remember we have our xn minus 1, say, and our xn, and then we find the average to find xn plus 1. So the error we kind of represent on average, it's the width of this interval, right? The width of these intervals, or 1/2 the width of the intervals. It doesn't matter. But the formula then would be the error in the n plus 1 step is going to be the error in the n step, but you decrease the error by a factor of 2, because you're always dividing these intervals by 2. Okay? The p here is a 1, so for a bisection, p equals 1, and we say the method is order 1. Okay? Method is order 1. That's the slowest method. We're going to compute in the next video the order of convergence of Newton's method. This is the fastest method, and I will try and show you that the order of convergence is 2. We can look at some numbers and see how fast something will converge if the error goes down as the square, okay, as the square. Secant method is somewhere in between, so p is approximately 1.6, which is still much faster than a linear convergence of p equals 1. Okay, let me summarize. I'm introducing here the concept of order of convergence of a root-finding method. The order of convergence is this value of p. The error in the n plus 1 iteration scales like the error in the nth iteration raised to the p power. Epsilon is going to 0, so a larger value of p will drive the error to 0 faster. Bisection method has p equals 1, so this is a method of order 1. This is considered a very slow method. Newton's method has p equals 2. That's actually the best you can do. That's considered a very fast method. And secant method is somewhere between. In the next video, we're going to have to do some sophisticated mathematics and try to find this p equals 2 value for Newton's method. I'm Jeff Chasnov. Thanks for watching, and I'll see you in the next video.